presenting the efficiency track first place solution. And let's get started. So I'll be giving a quick background of myself. Then we can go to the summary of the solution. Then the method I use for generating the synthetic data, the training methods. Now for the efficiency track, the trade-off between the time and the score was quite important. So just some methods I used to optimize for that. And then the main idea that gave quite a substantial, maybe surprisingly too much boost was model merging. And I'll discuss some findings from that. Yeah, so my background is I'm a ML engineer at H2AI, and I work on multiple problems, computer vision as well as NLP, primarily NLP in Kaggle competitions, maybe not too many, maybe 2 or 3 that I've taken part in. And of course, fine-tuning neural nets I've been doing pretty much before that, since like when computer vision models were a big thing. So it's been a longer time for that. Then the summary of the model is pretty much one embedding model because it has to run really fast and there's a very steep trade-off after a certain point of time. So it's 1, 2.5, 0.5 the backbone as an embedding model. Then prefix caching, which gave a big speed boost, and the additional misconceptions, without which pretty much the scores had a big drop. So I generated data with both Claude Sonnet and GPT-4o. And yeah, just very simple training pipeline, nothing very fancy, but I'll discuss those things. And then something that I wanted to improve the models for, which I knew that it does improve the scores a bit, but it ended up improving the scores more than I expected, which is merging models with Slurp. Yeah. All right. So for the synthetic data, it's a very simple pipeline. We first generate the subject, the construct, and the question based on the misconception, and then make the LLM solve with a full chain of thought to actually get the correct answer as well as the incorrect answer. Without it, the quality of the generated answers were much worse. So just adding that chain of thought helps. Then each dataset record is just one of them. I do not generate multiple choice questions. It's just one correct and one incorrect answer. And then to verify whether the generation was correct, actually using the other LLM, it seems to be better than using the same one. So if I generate with Claude, then I verify with GPT-4o and vice versa. And I tried to focus more on whatever was missing, as well as some of them which are very underrepresented. Maybe there's only 1 or 2 examples in the data set of that misconception. I tried to generate more of those and just have few more examples of those. So I think try to zoom in a bit here. So yeah, the prompt is not too complex per se. I had to just play around with looking at what mistakes the model is making while generating small bursts of data and looking at what mistakes it's making and just adding that into the data set to make it better. Then, yeah, and of course, just using the chain of thought to actually look at the correct answer. Then for verification, again, it's nothing too complicated, but I did think that instead of, I did try the scoring idea that I think one of the solutions have also mentioned, but I found pretty much it has to satisfy all these criteria. So it has to be relevant as well as generate the correct solution and both not be the same. So even they might be slightly different lexically, but sometimes they're same. So all of those conditions have to be met, and once those are met, I only keep the ones which are higher quality based on that, and that way I got a better data set. Then pretty much training the model is somewhat straightforward. We take a 2.5 0.5b model and use last token pooling with simple sentence transformers from Hugging Face, and I add a 1024 dim layer for the embedding. Training pipeline, I used the cached multi-negatives loss, which is, I think, pretty much most of the top teams used a similar approach for the embedding model training. And the hard negative mining may or may not have helped too much, but I think I was sticking to this approach pretty much for the entire competition. So just using hard negatives from BGE large. And I trained many different models with different hyperparameters, and merging them at the end actually helped out. So just training different models here was helpful. So I think pretty much it was not too dependent on the hyperparameters, but it was more dependent on the quality of the data set. Then the time optimization is where the significant portion of the efficiency track was useful. So I had wanted to figure out what kind of time versus score trade-off is there, and if I do the math, if I assume that let's say 0.6 is the average score, so the top score for the private leaderboard, then it would be 9 minutes for a 0.01 improvement. Now, if we just take any model like a BG large and fine tune it on my data set, depending if the quality is better, maybe it gets to a 0.28, 0.27. But from there, even improving a little bit seemed to be quite hard. So what was important is, even if I increase the model size significantly, that let's say I bump the model size from a 0.5b to a 1b model, which can increase the time quite a bit. It can increase the time more than double, but it hardly gives me a 0.1 improvement, a 0.01 improvement in score. So just trying to limit it to this kind of 10 to 15 minutes window is what I felt that it would be a good solution for this score, how the data set is set up. And that's why I got to this idea that, okay, if we use prefix caching with a decoder only model, so I can go to the next slide for that. So if we see the smaller models which are common in Hugging Face, in the BG or GT, these are all encoder only, full attention. And that means that I cannot have any kind of KV cache for these models, versus if I use a Quen model, which is the decoder only, I am able to use prefix caching on the 3 incorrect answers. So there are 3 distractors. I'm able to use the KV cache of the entire input of that and only change the incorrect answer. And that gives about 2x speed boost. If I try to optimize it more, maybe it gives slightly more, but just naively implementing it, it gives a 2x speed boost, which is pretty good. So my final solution takes about 14 minutes for this 2.5 model, versus same 400M size model would take something around 28 minutes or 30 minutes on an encoder only model. Now coming to the big solution here, which is the model merging. Now, just a bit background about model merging. So this is different from what you might hear about LoRa merging. So LoRa merging is about combining, LoRa merging is about taking the weights of the LoRa layers that have been trained and then putting it back into the model layers itself, versus here we are actually joining 2 separate models and interpolating whatever vectors reinforce each other there. So we combine them with this method called slur, And because these are trained on slightly different data sets, folds of a data set, slightly different hyperparameters, but they point to the same task, they can improve the score overall by a decent margin. Now, for smaller data sets and weaker models, generally this works better. So I was expecting maybe 0.01 to 0.015 improvement, but what I got was quite a bit more than that. I got almost a 0.25, 0.25 improvement there. And just this alone pretty much gave me, a significant boost to jump to the first place of the leaderboard. And now the difficulty with this is pretty much there's no proper way to know when, because it's a small data set, when it is like I'm overfitting on this test data set that I'm merging with. So it turned out that 6 models that I merged with the final, it was best on my CV, but it turned out to be the 5 model merge was better, but it's still pretty stable. So that was good. It improved the public as well as the private leaderboard. And yeah, that essentially is the main component which gave the final improvement. And the best part is that because we are combining the weights, it is just no increase in time. It's just like flat. In the same time, we are getting a better model. Yeah, so that's the end of it, and we can take some questions.